Welcome back. In this next section, 2.4, we're going to continue our conversation about linear equations, but we're going to dive into some more things about them. Today, we're diving into the idea of the other two ways to represent equations, point-slope form and standard form. So point-slope form, as its name implies, you are looking at your slope and you're looking at x and y values from a point on the line. So when I say y minus y1 equals m times x minus x1, this y1 and x1, they come from a point on the graph. Okay, x and y themselves are still the variables. X1, y1 are from a point. Okay, now there's a few situations where this is actually very useful to have. All right, so point slope form is useful to use when you're given a point and a slope. So kind of as its name implies. Okay, and the reason this is so helpful is because look at what I can do. I have the equation for a line passing through the point -1, 3, and it has a slope of -2/3. So literally, all I have to do is put it in the equation. Y minus the y value from the point equals the slope times x minus the x value from the point. Well, minusing a -1 is the same thing as adding 1. So this is the point slope version of that line. Okay. Now, the neat thing is though, that I can go between forms. We already investigated yesterday that I can convert things into slope-intercept form. So if it tells me to put it in slope-intercept form, what that means again, solve for y. All right, so that's going to mean distributing this out. So I'm going to have 1 minus 3 equals -2/3 x minus 2/3. And now I'm going to add that 3 over to get it away from my y. So I'm going to have y equals -2/3 x. Now, -2/3 plus 3. Okay, let's say we're not the best with fractions. Well, I can let the calculator help me with this. Okay, so -2/3, oh, -2/3. And I want to add 3 to that. Now, I don't want this as a decimal, okay, because it's nasty, never ending. So on my calculator, I'm going to math frac that so I can see 7/3. Okay, so this would be plus 7/3. That would be my equation in slope-intercept form. Okay, so these two equations represent exactly the same line, just in a different form. That's going to be one of the key things about this section, is being able to manipulate between forms. Not only knowing how to write the equation in point slope form, but then can I manipulate it from there? Okay, so let's do another example of this. So I have the point 7, -1, slope -3. So my go-to place is going to be point slope form. I'm given a point and I have the slope, so it makes sense. Y minus the y value from the point, minusing a -1 is the same thing as adding 1, equals the slope, x minus the x value from the point. So I want to start in point slope form, okay? That's going to be the easiest way when you're dealing with a point and a slope. Put it in point slope form. And then it says simplify to slope intercept. So you always want to note if you need to simplify it from there, okay? What form does my answer have to be in? Slope intercept means solve for y. So it means distribute that -3 and subtract the 1. So once again, these two equations say exactly the same thing. One is just point slope form, the other is slope intercept form. And I need you really, really good at manipulating between those forms when I tell you to, okay? Always start in point slope and then see, hey, well, how does my answer have to look at the end, okay? So let's look at the other situation, okay? So it's also helpful when given 2 points. When you're given 2 points, though, there's one additional step, all right? That additional step is finding the slope, and then you can use point slope form, okay? So here I'm given 2 points, so I'm going to find the slope between them, okay? Because as point slope form implies, I need slope. y2 minus y1, x2 minus x1, so 8 over 2. So here, my slope is going to be 4. So now, if I'm writing my equation in point slope form, this time there's actually 2 ways I could write it. I could write it using this point. Y minus the y value from the point equals the slope x minus the x value from the point. Or what else could I do? Well, or I could use that point. Y minus the y value from the point equals the slope times x minus the x value from the point. So in that case, I could have 2 different answers, okay? But they actually represent the same line. But you only need one or the other, okay? And I'm going to show you why in just a second, all right? So let's practice the same skill. I'm given 2 points. So let's look at the slope. Y, or y2 minus y1, x2 minus x1. And I'm going to get 7 over 5 because subtracting a negative is the same thing as adding. So when I go to write this, okay, so that's my m. So if I'm using this, y minus the y value from the point equals the slope x minus the x value from the point. All right? Or you could write this. Y minus the y value from the point equals the slope. Oh, I'm sorry. The slope times x minus the x value from the point. Okay, so remember, point slope, you can use either point. You only need one of the answers, though. But I want you to notice, simplify to slope-intercept form. So I want to show you what happens, okay? No matter which equation you started with, I want to show you what happens with this, okay? So here, y minus 0 is just y equals, and then distribute that. So 7/5 x. And now, again, let's say you're not the best with fractions. 7/5 times 5 just leaves you with the 7. The 5's kind of cancel each other out. Okay, so plus 7. Over here, well, this just cancels out. So basically, you just have y minus 7 equals 7/5 x. So y equals 7/5 x plus 7. So notice, when you simplify them to slope-intercept form, it didn't matter which point you used. You got the same equation. Okay, so that's why you only need to use one or the other. Okay, I just wanted to show you both so you can understand that in slope-intercept form, they look exactly the same to convince you they are in fact the same line. Okay, just the point-slope forms look a little bit differently. So again, just to reemphasize, this is a point-slope equation. This was the point-slope equation, just using the opposite point. These are the slope-intercept equations. Always get used to which form are you looking at, which form do you need. Okay, that should always, always be in your heads. Now, there is one more kind of equation that we're going to talk about, okay? So here, standard form means ax plus by equals c, okay? So that's the general form. What does it mean? Well, it means two things. It means getting rid of the fractions, and it means x and y need to be together, okay? So let's take a look at these, following those two rules. The standard form, x and y are together, and no fractions. Well, here, to get rid of this fraction, I'm going to multiply everything by 5. Okay, so 5y equals, it cancels off the fraction. Okay, so first step, I would get rid of the fractions. That's usually the easiest way to start. And now you need to get the x and y together. So I'm going to subtract the 2x over till we with the y. Now, something that our textbook isn't that concerned with, but at the college level they are, is there's actually one additional step, okay? So there's this, but then some say, you know what? This coefficient needs to be positive. Okay, at the college level, that's typically what they say. Again, our textbook, not as important, but at the college level, they want the x coefficient to be positive. So what they would do is they would flip the sign of everything to make the x coefficient positive. Okay, so either one of those are sort of standard form, just I need you to understand that at the college level, if you see them doing this, that's why, okay? They want the x coefficient to be positive, to be in true standard form. Now let's look at the other one. So here I see a fraction. So I'm going to multiply everything by 4 this time. So I'm going to have 4y cancels off that denominator. So I got rid of my fractions. Now let's get x and y together. So I'm going to add 3x over. This time, the x coefficient is already positive, so our answer is perfect as is. All right, so that's the idea of manipulating it to standard form, okay? No fractions and get x and y together, okay, are the two main steps that we're talking about. So can we incorporate this into some of the things that we've already done? And the answer is, of course we can. Now, you always, always want to start with point slope though. Okay, whenever you're dealing with a point and a slope or 2 points and they're saying, hey, write this equation, typically the easiest way is start with point slope. Okay, so y minus the y value from the point equals the slope times x minus the x value from the point. Okay, so again, more often than not, you're starting with point slope and you're looking to see what is my end game. Here, my end game is get it to standard form, okay? So no fractions and x and y together, with the constant on the opposite side. So standard form has no parentheses, so that's going to be my first step. So negative 4x, negative 4 times negative 1/2. Again, let's say you're not good with fractions. Well, don't be afraid. Type it in to the calculator. Negative 4 times negative 1/2. That gives me a positive 2. I'm going to add that 1 over so I can combine those. So y equals negative 4x plus 3. But to be standard form, I need the x and y together. So I'm also going to add that 4x over. And this would be standard form, okay? X and y are together, and there's no fractions. All right, let's look at our next example. Write the equation of the line through the pair of points, write in all three forms, okay? So, remember, the starting point is going to be point slope form, okay? That's going to be the easiest one to start with. So point slope form, because I can see, or I know how to get my slope, subtract the x's, or sorry, subtract the y's, subtract the x's, so negative 2 over negative 4. I'm going to have a slope of 1/2. All right, so point slope form, y minus the y value from one of the points. I'm going to go with the one with smaller numbers. It just seems easier to work with. Y minus y value from the point equals my slope, x minus the x value from the point. So here, I already have my point slope equation. All right. Now, let's keep this going. Okay, so to keep this going, I'm going to distribute the 1/2. Again, neither slope intercept nor standard have a parenthesis in them. So by distributing, I'm going to get this. 1/2 times 2, so it's going to leave me with that. Add the 3 over. So here, I solved for y. So that is my slope-intercept equation. All right, so now I've already hit 2 of my 3 equations. All right, let's go for the last one. Let's go for standard form. Standard form means no equations, or sorry, no fractions. So I'm going to multiply this whole thing by 2 to get rid of that. So I have 2y equals, that gets canceled off. So now my fractions are gone. So I'm going to subtract the x over. So it's with my y. And again, a lot of textbooks at the college level say don't let that coefficient be negative. So they would flip the sign of everything and call this the true standard form. All right, so that's how I would work through. That is the manipulation process for me to go between any of the forms. Okay, so in this one question, we hit all 3 forms. And I do need you kind of fluid between them so you know when I say, hey, put it in this form, put it in that form, you know exactly how to go about doing that. So that would be a good thing to talk about in your summary. what does this process look like? How can I tell the difference between these forms? How can I go between these forms? Because that's really the big idea. Can you write it in point slope form, and then can you manipulate to one of the other two when I say so? So please make sure to take a moment and write that summary, and then come back ready to do your practice work.